So you want to build an amplifier. You know, you're a speaker builder, what have you. You know that you want to build something that looks like this. So you know you want to build this, and that's about all you know, right? You're brave enough to do it. And at the next slide. And we know that the block diagram, okay, we know that the block diagram is something like this. You know that we've got AC, we've got a box, the amplifier, and then we got our speaker hooked up to it, and that's where the music comes out, okay? So there's some steps in here. So let's talk about those steps. Next slide, please. Okay, so there's the inside, and we're going to look at this picture later, right? But this is the preview. So take a glance at this. We know that we've got power here. We know that the power goes to something for inrush, and we'll call it soft start. I refer to it as soft start. It's not entirely, but it's close enough. We've got a transformer, right? We've got some diodes. We've got some power supply, and we've got an amplifier channel. There's an amplifier channel over here. Okay, so what are all these wires here? This is about as simple as I can wire one of these. And we'll go ahead and move on. So let's take a look at this. So let's take that and expand the block diagram one more. Do you like my CAD software? Doesn't that look sharp? Yeah. It was desktop, and they call it like pen and paper, I think. So we've got AC power coming into the box. We've got the power supply. Power supply is going to have a number of pieces in it. And then we've got the amplifier, we've got the output. So we've got wall current, and we've got our speaker here. Next slide, please. Okay, so the power entry module, that's what these are referred to as. Some people call them IECs. That's actually the standard for the plugs is actually IEC. So this is considered a power entry module. They usually have, and the ones that we spec will almost always have, a switch on it, as well as we'll have a fuse holder. Okay, and having it all in one place means that you have fewer and fewer wires to deal with. So using a PEM is actually a great idea. Next slide. Okay, so again, just schematically, we've got a cord to the wall. We've got the power switch. The switch schematic diagram is this. It's sort of like you've got a closing gate, right, that makes the connection. And then this little wiggly line there, that's the fuse. So we got the fuse holder. Next slide. All right. The back of the PEM is going to look like this. My apologies for people looking at this in the future. This is an old photo. I had to grab it quickly, and the color coding is wrong. It's correct here. It's not right here. Okay. Safety earth. This is sort of the most important one. This is the ground plug on the cord, right? Everything that we're going to make when we're dealing with the transformer that's DIY, we have to have safety earth grounded to the chassis, bonded well. You want to use lock washers that have teeth in them. You want to make sure that it is touching the chassis, right? Safety earth is what keeps you alive if something goes wrong, right? We had a builder in F5M thread recently whose power supply was doing all sorts of screwy stuff. It was burning up the thermistors, and it's like, well, we've got a short. We know where it is. We can see that happens, and he'd move stuff, and the short would move, and it's like, what's going on? And it turns out that he didn't put the rubber washer underneath the transformer, and there was a short in the windings going to chassis, and what kept him from hurting himself touching the metal was the fact that this was hooked up, right? So it's absolutely fantastic. In American AC wiring, wall wiring, you've got typically two colors that are in the wall. We use this in the wall. You've got black, which is connected to the live. And then you've got white, which is connected to the neutral. This is a 120 volt US AC thing, North American AC thing, where we only use one positive phase and we have a return. The color coding is very simple. The live is the one that is connected back through the breaker that's touching the power station. Right? Why is it black? Because that's the color your finger will be if you touch it. Okay, and then white's the neutral on that. In European coding, I should have these flipped. I should have the neutral is blue, and then the brown in European coding is actually the first phase is actually live. Next slide. So that's the inside of the PEM. Again, schematically, we've got the power cord coming in. The fuse is before the switch. Very important. The fuse has got to be before the switch. First thing you do is you fuse it. And then the fuse and the switch, again, in North American 120, is on the live. The neutral just passes through. There's your color coding. And then safety earth is connected immediately to ground. The ground symbol that has the rake-looking thing means that's the metal connection to chassis. Next slide. Sometimes you'll see power entry modules that have RF filters, like Bob was talking about, and they usually have just little tabs right on the back. You can't screw up the wiring as long as you see where the L and the N is, which is kind of nice. Next slide. Okay, so this is the final drawing. We will come back to this after we've talked about it. We've got the power entry module. We then take the AC from the power entry module. We go to the soft start or inrush protection. There's different ways of doing this. I'm going to show you the simplest. We then go to the power transformer. The power transformer primaries go into it. This is where you've got the wall voltage is here. Then you have the secondaries, which is where the changed voltage is of the transformer. That goes out to the diodes. The labels are up here. You can't see it. We go to the power supply. We have DC here that's all smooth, ready to go to the amplifier. Typically in a first watt, we have a bipolar power supply, meaning that we have a positive, a ground, and a negative voltage. And then we have, this is like an RCA input, which is drawn very badly. And then we have our speaker and our smiley face music coming out from the output of the amplifier. Next slide. Okay, so soft start. Go to the next slide, and then we're going to go back one. Okay, so Randy Thatcher DIY Audio on Etsy, and this is stuff's going to start showing up in the store as well. He makes these little teeny circuit boards, right? These are like, 1.5 by 1.5. They're like 30 by 30, 35 by 35 millimeter. They're not very big, and they hold 1 or 2 thermistors and a line cap, and you can either put the blocks on it or you can put, 1/4-inch quick disconnects to do the soft start. These thermistors are used to make it so when you turn the power on, there's a big resistance in between the transformer and the wall. So when the empty capacitors, which look like a dead short, are empty and filling up, it actually acts as a little bit of a throttle just for a little while to make it so it doesn't blow the fuse when you turn it on. Right, so you have to have some kind of soft start in there, and putting a thermistor in, big power thermistor, is actually a good way. Can we go back to the previous slide, please? Okay, you made it. Okay, so live AC from the power entry module goes into this. I said we're going to call it soft start. It's got a line cap. It's got some kind of thermistor. That's the symbol for a thermistor. That's the symbol for a capacitor. And this, then you have the same, basically it's still wall current coming out of it, so you have to still watch your phase, which one's live, which one's neutral. Another thing that's worth pointing out on the soft start board is you have to use an X1/Y1 line rated capacitor, and this is very, very important. I learned recently, I thought I was completely wrong, I was backwards on it. Line rated capacitors are designed to be used across the AC line, and when they fail short. I always thought it was the other way around, but line rated capacitors fail short. So if there is an error, it blows the fuse. If the fuse doesn't blow, it blows the breaker, right? But that will stop the error, right, in the line, and it will go ahead and turn it off. So you must use an X1Y1 or X2Y2. It's got to be a line rated cap on here. Value is relatively is not particularly important. 2 slides, please. We're going to go past that. We've seen that. Okay, so now we get to the transformer. Okay, yes.
And the capacitor
Let me do Tom first.
So I would like to add something to something you said previously, where you charge the capacitor bank.
Yes.
You also charge the magnetizing inductance of the transformer.
Yeah, absolutely.
That can draw like hundreds of amps, especially for a large like 1 kVA transformer. So that's where the soft start comes.
Yeah, absolutely. Tom's 100% right. There are 2 things that are being charged. Yes. Oh, so that capacitor is there for safety because it is a line rated cap. So if there is an error, somehow if you get an over. No, it's not a surge cap. It does filter out. Oh yeah, okay, yeah, no, that's actually a good point. Thank you for bringing that up. So that cap does a couple of things. It's a spark quenching capacitor, right? Because when you turn the power on over a switch, you'll sometimes get sparks, right? That cap actually helps keep the sparks down. That capacitor does filter a little bit of high frequency noise off the line, and then it also is a safety cap if you have an egregious error in the wiring. Does that answer it? Bob.
Also under the impression that the RFI filter actually usually has the X and Y capacitors as part of its function.
Yes. Yes, absolutely. Having another one's not going to hurt anything.
Yeah.
Yeah. Yeah. Belt and suspenders if you have a filtered one and this. If you have a cheap IEC, because a filtered IEC is usually $15, $20 more. Yeah, they're a lot of money. So now you get to the transformer, okay? And when I hang on, when we get to the transformer, now when I showed this slide to somebody, they immediately laughed and they giggled and is like, "Yes, I intentionally drew it to be nasty." So you got a bunch of wires coming out of the donut, right? And you know, you've got the blue ones and you got red ones and black ones and green ones if it's an Antec, but you know, depending on the manufacturer, the colors are going to vary. Next slide, please. So how are you going to hook up this mess? Okay, well, you can see that this winds up being a soft start of types. This is sort of the old way of doing it. I'd like to get away from this because that's all exposed AC there. So let's not do it that way moving forward. These are the primary windings. You can see that that's coming from the AC going into the transformer. And these are the secondary windings coming out going to the diodes, right? Next slide. All right, so how is this drawn? Here's the transformer schematic, right? And I like transformer schematics a lot, even when they're drawn, you know, all sloppy like this. You got the primary, which is the side that touches the AC from the wall, and then you have the secondary. The first thing you want to notice about transformer is that there is no electrical connection. Right? There's no wired connection in between the two halves, right? You've got the metal core in between the two. So you have windings of wire around the core. Everything is insulated, right? And then the primaries will go ahead and energize and make a field in the core. And then you wind more windings around the same core, and that actually is what in a different ratio, which actually moves the current across. But there is no wired connection between the two. So some people talk about it being an isolation transformer as well. Isolation also means that there's usually no voltage movement, but you do have an isolating effect for it. This helps with overall safety that I'm not going to get into. If you ever see a schematic where it basically DC rectifies the wall, do not build it. When they talk about the death cap in old guitar amps, yeah, don't build it. Okay, one thing that's worth note here is that this is a dual primary, 115 or 120 volt. You've got two of them, and these are going to need to be connected to the live. These are going to need to be connected to the neutral. If you're in 240, you tie these together, and now you'd have a 230 volt winding across here. I'm only going to show 115 so I don't run out of time. On the other side, typically for a first watt, we use 18 volt transformers. So there's an 18 volt winding, there's an 18 volt winding. On some transformer schematics, but not all, they will have these dots at the beginning of the winding. So you have the lead of the winding where they start winding it around the core, right, physically, and then where it comes out will be the trail. And you want to make sure that if you have paired ones, you all have them in the same phase. So know which one is the lead winding, we know which one is the trail winding. That shows up again later. In Antec colors, that's not Cantec, that's Antec, we've got green and blue. So green is the lead, blue is the trail. And then on the primary, red is the lead and black is the trail. This comes up again later. Next slide, please. Okay, so same schematic, labeled differently. We've got AC from the soft start, right, which is going to go, and we're going to have our primary. So this is the red, that's the black in Antec, right? Everybody's different. But in Antec, this is the red, that's the black on the primary. That's connected to the live, that's connected to the neutral, and then on this winding, same thing. So this is going to be parallel with the live, this is going to be parallel with the neutral. The secondary windings, which in Antec are green and blue, are going to be connected to the diodes. Next slide. Okay, so here's the transformer. Here's some diodes. We're going to talk about these in just a second, and then you can go ahead and see the windings in green and blue. Now, it doesn't matter which way you've got the greens and the blues, as long as they're consistent between both. That's all that matters, okay? Next slide. Okay, so let's talk about diodes for a second. Again, we've got AC from the transformer going into the diode. Sometimes you will see a diode bridge drawn like this. Sometimes you'll see it drawn like that. You have AC coming in, that's what the little wiggle is, the tilde looking thing. And I'm really lazy, so they look like that. And then you have plus DC and minus DC out. Okay, so this is schematic. That's schematic. You can see the arrangement of the diodes, AC, AC, minus, plus. And then looking physically at the diode bridge itself, you will typically, not always, have a notch in one corner on the package itself, which says where plus is. And then notice that the terminals, you got three in this in one direction, and you got the one that's 90 degrees off. The one that's off is the plus, and then the negative on a four bridge is going to be the one that is opposite diagonally from the plus and AC there. They're labeled around the perimeter. Tom.
On some of the flat bridges, it actually reverses depending on the old. I've had 1,000 bridge that was marked differently than me.
No kidding. Wow. Yeah, that I had no idea. I hadn't come across that. Yeah, so keep your eye out. Look at the labeling. I mean, that's sort of, responsibility 101. Yeah, exactly. Next slide. Okay, so this is a different direction. Imagine the transformer is over here, and that's power supply is going that way. So again, you can see that the transformers would attach here, right? AC in, and then it's kind of hard to make out, but you can see that that's the 90 degree down there. So that's red. And ignore the color coding on here. Look at that. That's still red. So we've got the negative of one bridge, the positive of one bridge, the negative of one bridge, and the positive of one bridge. And for those people who are scratching their head is how we can have the plus and the minus connected to the same node on this. That's magic. We'll get to it later. But it works. Next slide, please. Yes.
Just wanted to point out on the transformer thing, sometimes there's an extra pair of leads that come out of the transformer that are normally shorted. And that's because the transformer has an overheat inside of it that will detect if the transformer is overheating, and that's like a little switch.
Oh, no kidding. I've never seen that. That's really cool.
The other thing is some transformers have a screen between.
Yeah, yes, they do. I'm ignoring it. But that's also very valid because most of my builds actually use screened ones. This is trying to keep it as dirt simple as possible. Okay, so now we get to the power supply, the capacitor bank, the smoothing that we associate as being the power supply, the thing that holds capacitors and maybe has some other kind of filters and some lights on it and so forth. Transformer, notice that doesn't have the same color coding we were talking about. This happens to be a Plytron transformer, but you just have to watch the labeling on it, read the data sheet, figure out what the wires are, and connect them as such. This connects to the power supply. We've got our smoothing, and we've got our good DC coming down off the bottom. So next slide. Again, this is what you associate with the power supply. You've got, the DC voltage from the diodes coming to the in. You've got all your smoothing, and then you have out. And typically, if we're building a first watt, again, it's a bipolar power supply. We've got negative, ground, and positive. Next slide. Okay, so again, we've seen pictures of this, but let's take a look at it schematically. We have our diode bridges. So transformer is here, right? We've got on the Antec, we've got the blue and the greens, which are attached here and here, here and here. Our 90 degree pin is the plus. There's a plus, there's a plus, there's a minus, there's a minus. And again, we've got our minus out, our green, our ground, and our plus out to the amp ports. Everybody following me? Cool.
Jim.
Next slide. Yeah.
Jim, can you hear me?
Yes, I can. Hi, Alex.
I just wrote on the chat, but it seems nobody is seeing. No,
yeah.
There is no need for exactly same phasing of secondaries when you are using arrangement with two diode bridges.
Well, yeah, I know that, but I want people to make sure.
Okay, for clarity and for clarity, okay, but electrically there is no need for that.
Yeah, and to Alex's point, that's ZenMod, by the way. To Alex's point, what he's saying is that you don't actually have to watch phase on the transformer secondaries. However, you do need to watch it on the primaries. And if you have a primary wired inside out, you're going to be popping fuses as soon as you turn it out. So from a neatness count standpoint, let's have them in phase on the primary and in phase on the secondary. Alex is 100% correct. However, I was presenting it like this because I want everybody to just be neater. Next slide. that too. Okay, again, schematically, now we've got the power supply. I'm omitting the transformer here. I'm omitting the soft start and the power entry and so forth. We got our diodes, we've got our power supply. We're now going to an amplifier. It's a F5 or a Babelfish or something awesome, right? Power goes in, we're going to have our speakers out, and we're going to have our RCA or our balanced in, but here's the input, there's the speaker, here's the power supply. This is making sense? Next slide. Okay, so yeah, okay, so this is an F4 for what it's worth. This is coming from the power supply. There's the plus, there's the neutral, or the ground. There's the V minus. You can see the RCA that's going to the input. You can see the speakers going out to the speakers, and you can see how the previous drawing looks a lot like this. Okay, next slide. Okay, we've seen this before. Does this make more sense now that we've gone over everything, right? We've seen every single piece of this. It's not drawn out in pure schematic, but this is a block diagram, is a little bit more filled in. Does anybody have any questions about this, or does it make sense? Hang on, Bob. Yes.
Since we're doing smoothing in the power supply unit, does it make any sense to buy smoothing or filtering in our PEM?
Yes, it does. It never hurts. PEMs with onboard filters keep grunge from the outside from coming in, and it also makes anything that happens to be inside from getting back on the line, which yeah, it's in my opinion, and that's worth, you know, $2 and a cup of coffee if I got $2 to buy the cup of coffee. I prefer to use filtered PEMs for everything, right? Yes, they're an extra 15 or 20 bucks, but it is what it is. I definitely prefer it. Okay, so we've got our power cord. We now know how to wire all of this stuff up to where when we start looking at other projects, it becomes more and more familiar, which was the entire point, and the music comes out. Next slide. So you haven't seen this picture, although you've seen the amp. So from the audience and the people who know what they're talking about, okay, so raise your hand if you've never built a first one. Okay, only you get to answer this, right? So what's going to connect to this thing here going outside? The power cord. Yep. Okay. So, and then you can see how this has got connections to this. And so what do we call this one? Soft start, inrush protection. And then the big donut-y thing with all the wires is the, okay. And then the diode bridges, and then we have the power supply or the smoothing capacitors, right? And then you can see that the power is connected here, goes to the amplifier, and then you can see there's the RCA into it. And really that's it. You know, that's about it. Everything else winds up being, you know, it's literal nuts and bolts as opposed to figuratively nuts and bolts. Next slide. I think it's the same picture. Yeah. And that's just the top view. Again, PEM, we've got AC. Remember, the switch is in here, the fuse is in here. We've got, that's AC, that's white and black, goes to the soft start. That's the transformer primaries. That's the transformer secondaries, diodes, power supply, filtered power supply connected to the amplifiers, speakers, RCAs. And I believe that's it. Tom, my sincere appreciation for stealing some of your time. I realize that we kind of, we're 20 minutes behind now, or 18. So Tom Christensen is going to speak next. And here's Tom. Thank you.